Hello again, my dear students. Today, inshallah, we are going to study trig lesson, relation between angles and trig functions and related angles. Still with me and enjoy mathematics, inshallah. Now we are going to draw a triangle here. We have a triangle. We only deal with right angle triangle, here, like that. We have A, B, C, and this is right angle. Say that this AB of length 3 centimeter and CB equal 4 centimeter. Then from Pythagoras theorem, AC equals 5 centimeter. We try to find the trig functions of the angle C here. We have sine C. Sine C equals what? From your studying before in Prep 3, you find out that sine C equals opposite side of the angle C, opposite over hypotenuse. Opposite we can say O, and hypotenuse we symbolize it by H, and adjacent side for it. Adjacent means that the side neighbor to the angle C, we find it as A. So sine C equals OH. What means O, opposite of the angle C, over H, which is hypotenuse. So it's equal 3 over 5. Okay. For another triangle, if we draw another small or big triangle than this one, we'll find that right angle triangle here. Right angle triangle, and we have C here, A, B, this is right angle triangle, and if we have this side equals 6 centimeter and this one equals 8 centimeter, then side AC, which is hypotenuse, equals 10 centimeter. If we try to find sine C here, sine C, it's OH, means that opposite over hypotenuse, equals 6 over 10. We find out that the answer will be 3 over 5. It is the same answer as the triangle before. We have 3 sine C here equals 3 over 5, and we have for this triangle also equal 3 over 5. So it's a function, because if we have see an angle in right angle triangle, its sine is constant for all triangles, even triangle big or small. Okay. Let's now, my dear students, go to another thing, which is unit circle. We have circles, many circles. We can draw many circles here, but unit circle has two conditions. Here we have a circle. We have circle here. We have x-axis and y-axis, x dash, and y, and here y dash. This is what? Yes, it's origin point. Okay, and we have here this line segment OA equals 1 centimeter or 1 meter. It's a unit. And OY dash here equals 1 centimeter also, and OB here equals 1 centimeter, and OC equals 1 centimeter. So its radius equals what? Equals 1 unit. So the unit circle here, unit circle, have two important conditions. Its center, M, center is origin point, which 0 and 0, and the radius equal 1 length unit. So we call it unit circle. Unit circle is very important for us for studying, and try with me to look carefully to slide here. Yes, we have a unit circle here. Look carefully to these numbers: 0.1, 0.2, 0.3, and 0.9, then 1. So its radius equals 1 unit, and its radius from here, all radii are equal, and all of them equals 1 unit. And we have the origin point, which is O in the middle. It's 0 and 0. Yes, what's the item of information do we need to define a circle? We said before that it has the center is the origin point, and its radius equal 1 unit. Give a unit circle. What distinguish the unit circle from all other circles? Identify the 4 quadrants. What direction do we move in going from the first to the 4th quadrant? We have here 4 quadrants. That is the first quadrant, second quadrant, third quadrant, and 4th quadrant. From left to right, anti-clockwise direction. How would you describe points on the circle or circumference of the circle? Read the Cartesian coordinates of points in each of them. We have a unit circle here, and we have many points here. We have B, C, D, and E. And the center is origin point 0 and 0. And radius equal 1. Any point in the circle, we call it X and Y because it is a coordinates, X and Y coordinates. So the ordered pair equal X and Y. Like B equal 0.6 and 0.8 here. X equal 0.6 and Y equal 0.8. Okay. Look carefully. In which quadrant are both X and Y positive? Look carefully here. We have here OX, which is positive, and we have here OY, which is positive, but OX dash here is negative, and OY dash here is negative also. In which quadrant is X positive? We said that. Okay, look carefully at this. We have here this point, origin point, and we try to draw any angle here. Our initial side will be OX here, the positive direction of x-axis, and yes, we have return 1 round, anti-clockwise direction to be positive angle. Let's see it again. It's enjoyable. Look carefully for this. We have here angles from 0 to 360. We revolve 1 turn, 1 round. Its measure equals 360 or 2 pi. Okay, we have here the first quadrant, include between 0 and 90 degrees. if we want to draw any angle here, we draw a ray from O, which is origin point, to OX to be initial side, and we draw an angle here which is 30. So we have Q. Q is a point on the unit circle, and this angle equals 30 degrees. How would you draw the angle negative 30? Look carefully. We have here a right angle triangle. This is right. We have here, we want to find sine this angle and cosine of this angle and tan of this angle. Sine will be opposite over hypotenuse. Cosine will be adjacent over hypotenuse, and tan will be opposite over adjacent. Sorry. Compare these with the values of x and y. Okay, my dear students, let me explain it to you now. We have here the unit circle, and we try to draw it with unity. We agreed that the center here is the origin point. We can make it clear to you. We have a circle here. We have origin point, and this is x-axis. I try to make it clear for you to see it well. We have here x-axis, and we have here y-axis. Yes, this is x, this is x dash, which is negative, this is y, and this is y dash. Okay, look carefully. If we have a point here, which is Q, and this point represents a terminal side like this, which is 30 degrees, and we drop a perpendicular to x-axis from this point. So this is O, which is origin, and this is x, and this part equals y, and this is right angle triangle, right angle, and this is the angle 30. And what is the length of OQ? OQ is radius, so its length here equals unity equals 1. So let's go to find out sine this angle. Sine 30 equals opposite over hypotenuse. So opposite here is y over hypotenuse, which is 1. So sine the angle equal y over 1, which is equal y. And what is the length of y here? Y here will be half, or 0.5, and x here, as we have seen in the slide, will be approximately 0.87. So cosine 30 will be adjacent, which is x, over hypotenuse, which is 1, equals x. That means equals 0.5. But sine 30 equals y. Y here approximately equals 0.87, or we can call it root 3 over 2. Okay, so sine 30 equals 0.87 and cosine 30 equals 0.5. Okay, or I'm sorry, I exchange it, 0.5 here and 0.87 here. So sine 30 equals half and cosine 30 equals approximately equal 0.87 or root 3 over 2. Okay, let's go to another paper. Here we will move to another unit circle to find out some sine or cosine functions. We have here a unit circle. This is a circle here, and we have x-axis here and y-axis, and we have any point as Q. If we drop a perpendicular, then this is x, this is y, and this is 1, and this is the angle of theta. What is the theta here? It's an angle starting from x-axis and its terminal side here, this side, which is OQ, and the length of radius equals 1 unit. So sine theta equal OH equals y, and cosine theta equals AH. A means adjacent over hypotenuse here equals x. So try to keep with me that we have sine theta equals y and cosine theta equals x, and this point we call it x and y. Here it's a coordinates. This is the x coordinate and y coordinate, and x equals cosine theta, y equals sine theta, but tan theta here equals sine theta over cosine theta equals what? Equals y over x. Okay, let's move to another question here. My dear students, we will talk about reciprocal of trig functions. Reciprocal means multiplicative inverse, and we can say that if we have here a right angle triangle like that, ABC, B is right angle here, and we want to find all trig functions. Sine C equals opposite over hypotenuse, and cosine C equals adjacent over hypotenuse, and tan C equal opposite over adjacent. So sine C equal OH, cosine C equal AH, and tan C equal OA. But we have reciprocal, which is multiplicative inverse. Okay, we have here sine 1 over sine C will be H over O. We call it cosec theta or cosec C, and 1 over cosine C we call it sec C, which is cotan C, which is 1 over tan C. My dear students, we have now a short break and we will return again. Yes, my dear students, hello again. We now go to find out new things and new questions about trig functions. Let's go to right angle triangle here. We'll draw a right angle triangle and let it A, B, C, and let me call this angle theta. We have AB equals 3 centimeter, CB equals 4 centimeters, and AC equals 5 centimeter. And we would like to find out all trig functions here. Trig functions are sine theta, which is opposite over hypotenuse, equals 3 over 5. 3 over 5. Opposite over hypotenuse. And cosine theta equals adjacent, which is 4, over hypotenuse, which is 5. Tan theta equal opposite over adjacent. Opposite here equals 3 and adjacent equals 4. And we try to find its reciprocal. The reciprocal of sine, it's cosec theta. Sine theta equals OH or 3 over 5. Cosec equal 1 over sine, which is multiplicative inverse. So it's equal 5 over 3. Sec theta equal 1 over cosine theta. It's the reciprocal of 4 over 5. So it's equal 5 over 4. Cotan theta equals 1 over tan theta. We can write cotan theta here to see well. Cotan theta equals 1 over tan theta. It's the reciprocal of tan theta, so it is equal 4 over 3. Okay. Let's go to another property here for sine and cosine. Sine theta and cosine theta, it is not more 1 and it is not less than negative 1. Let's see here. We have a unit circle. We can draw a new unit circle here. This is y-axis. This is x-axis. And we try to draw a fine circle using compass. And to be clear, I can draw it again using this pen. We have here x-axis. It is the positive direction of x. It is the origin here. And y-axis. X here will be negative, so it's x dash, and y will be y dash here. X here is positive, but here is negative. Y here is positive, and here is negative. So, if we try to find out any point here, Q, and we have an angle theta, and drop a perpendicular here. So here it's x, here is y, and this radius, which is hypotenuse, equals 1 unit. And we have here the point 1 and 0, but here will be negative 1 and 0 because x is 1 here but in the negative direction, so it is negative 1 and 0. Here it's 0 because x here is 0 and 1. This is the positive direction of y-axis. This point will be 0 and negative 1. And let us see the angles here. We will start with 0, then 90 degrees, which is equal pi over 2 as a radian. Here will be 180 degrees, which is equal pi. Here the angle will be 270 degrees or equal 3 pi over 2, and here 360 degrees, which is equal 2 pi or 0. Okay, so if we want to find sine 0 as example, sine 0 equals what? We agreed that sine is y and cosine is x. Okay, but 0 its terminal side here on OX, so will be 0. Okay, but cosine 0 will be 1 all the radius. Okay, here in this point, if we would like to find sine 90 and cosine 90, we agreed that cosine equals this number and sine is equals this one, so cosine 90 equals 0 and sine 90 equals 1. Look here, if you would like to find sine what? Sine 180 and cosine 180, sine equals 0 and cosine equals negative 1, and look here, which is 270, sine 270 equals what? And cosine 270 equals what? Cosine 270 equals 0 and sine 270 equals negative 1. And here is 360 or 2 pi or 0. So look carefully at these numbers. We have sine here equals 0, sine 90 equals 1, sine 180 equals 0, sine 270 equals negative 1. So the smallest number here is negative 1 for sine, any angle. And the greatest angle here, or greatest value here, equals 1. So we can say that sine any angle theta, it belongs to the interval which is included between negative 1 and 1. It can be negative 1, negative half, 0, half, 3 over 4, 1, and so on. But not less negative 1, not more than 1. And look carefully for cosine. We have here cosine 0 equals 1, cosine 90 equals 0, cosine 180 equals negative 1, and cosine 270 equals 0. So we can see here that the smallest number can an angle of cosine take it is negative 1, and greatest number is 1. So cosine theta also belongs to the interval closed negative 1 and closed 1. And the cosine value include between -1 as a minimum, it is -1 or more until 1. Okay, so we agreed that sine or cosine can be -1 or 1 or any number between them. Okay, let's move to another thing here. Yes, trig is very important for you, not for first secondary only, but also for second secondary, inshallah, and third secondary. So look with me carefully. We have here another question to answer. If we have a point, we call it A. This point equal, or ordered pair, equals 3/5 and 4/5. And we would like to find out all trig functions for it. Trig functions mean sine, cosine, tan, sine theta, cosine theta, and tan theta. And also we can go to its reciprocal, which cosec theta, sec theta, and cotan theta. Look carefully here. We agreed that this is x and this is y as the coordinates. This is point on the unit circle. He must tell you that A is a point on the unit circle. So we have cosine theta equals 3/5, and we have sine theta here will be 4/5. So cosine theta equals 3/5 here, and sine theta equals 4/5. Tan equals sine over cosine, so it's 4/5 divided by 3/5, which is equal 4/5 times 5/3. We cancel 5 with 5, so it's 4/3. And we have the reciprocals for these angles. Sine, its reciprocal is 5/4 here, and reciprocal of cosine, its sec, equals 5/3, and cotan theta is reciprocal of tan theta, which is 3/4. Let's move to another question. Yes, my dear students, we have many questions here to solve. So look carefully with me. If we have another point, we call it whatever, say B. This angle, this point B on the unit circle, and it's -12 and y. Yes, this point on the unit circle, and we would like to find all trig functions for it. So let's go to this one equals cosine, but we have y here. But it's very important to study unit circle again. This is a unit circle. Look carefully for it. Unit circle here. We have here x-axis, x dash, y and y dash. And we know that this point is the origin point, and radii here equals 1. Okay. We have a point here as a Q, and we drop perpendicular to it. So we have here x, y, and the radius, which is hypotenuse of the right angle triangle, which is equal 1 unit. From Pythagoras theorem, we know that hypotenuse power 2, which is 1 power 2 here, equals what? Equals x power 2 plus y power 2. X power 2 plus y power 2 from Pythagoras theorem. So we have x power 2 plus y power 2 equals 1. So let's applicate that to find y in the point negative half and y. Negative half and y, it is a point on the unit circle. So this number, which is x, we can put it like that, negative half power 2 plus this number, which is y power 2 equals 1. Negative half power 2 equals 1 over 4 plus y power 2 equals 1. So y power 2 equals 1 minus 1 over 4. So y power 2 equals 3 over 4. By taking square root for the two sides, we will find that y equals positive or negative square root 3 over 4. So let's move again to the question before. We have here, we have found that y power 2 equals 3 over 4 and y equal positive or negative 3 over 4. And he told that y here is greater than 0. That means that this number will be positive. So x will be negative half and y will be root 3 over 2. This is the point B, which is on the unit circle. So let's find out all trig functions. We have here sine theta, cosine theta, tan theta, and we have their reciprocals, which is cosec theta, sec theta, and cotan theta. We agree that sine is the y, so it's root 3 over 2, and its reciprocal will be 2 over 3, of course. Cosine theta equals negative half, and its reciprocal equals negative 2 over 1 over or negative 2. Tan theta will be sine over cosine. Sine will be root 3 over 2 divided by cosine, which is negative half. So it's equal root 3 over 2 times negative 2 over 1. Okay, 2 cancelled with 2 equals negative 3. So tan theta equals negative 3 root 3, and its reciprocal cotan theta equals negative 1 over root 3. Okay, my dear students, let's go to another question here. Yes. Let's move to another one. We have another point on the unit circle, which is C as example. We have negative x and x. This point, we agree that it is on the unit circle, and we want to find out all trig functions here, which is sine, cosine, tan, cotan, sec, and cosec. We have C on the unit circle, so we will find out that x, negative x power 2 plus x power 2 equals 1. And he told me that x will be positive, greater than 0. Okay, that will be x power 2 plus another x power 2 equals 1. X power 2 plus x power 2 here equals 2 x power 2 equals 1. x power 2 equals half, and x equal positive or negative square root half, and ignore negative because he said that x greater than 0, it will be positive, so x equals root 1 over 2 means 1 over root 2. So this point will be C will be negative x, which is negative 1 over root 2, and x will be 1 over root 2. Sine theta here equals 1 over root 2. Cosine theta will be negative over root 2, which is 1. And tan theta equals sine over cosine, so it will be negative 1. And easily you will find its reciprocal. Let's move to another example. Okay. We have missed the last episode about a question here. I would like to explain it to you, so concentrate with me, please. We have here many circles, but here they have the same center. Okay, center here is M, and we draw like that. Or we can draw another circles like that, and we have the same circle, and draw one ray and another one. We have the center here M, and all these circles have the same angle, which is theta, but different arcs in length, L1, L2, L3, and different radii. This is the radius, this is another radius from this point to this point, and R3. When we calculate L1 over R1 here and L2 over R2, L3 over R3, we have found that it gives us the same theta, the same central angle. Even these circles are different in size or in radius. So it's theta rad here, and also it's theta rad here, and theta rad here. So we have the same central angle for many circles but have the same center, and different lengths of arcs which opposite to the same theta, which is central angle, and different lengths of radii. So we go to this rule. We have here a magic triangle to write this rule. We have L, which represents the length of the arc, and we have here theta rad and radius. To find L, just multiply theta rad by R, radius. To find theta rad, divide L over radius, and so on. To find radius, of course, you can divide L by theta rad. And we have deduced that this rule is work, or it's right, because L equals theta rad times R, R equal L over theta rad equal L over R. Let's move to another question here. We have a question for you. If we have radius equal 12, radius of a circle equal 12 centimeter, and the length of the arc equals 8 pi centimeter, we want to find theta rad. I remind you with the magic triangle here, we have L, theta rad, and we have radius. L equals theta rad times R, but we want to find out theta rad here, so theta rad equals L over R, so it's equal 8 pi over 12. In simplest form will be approximately 2.1 rad. Okay, it's easily now we found the theta rad if he gives us radius of circle and length of the arc. Let's move to another question, my dear students. Let's move to another question here. A question: if we have a circle like that, and we have a right angle triangle, center here is right, A, M, B, and we have the arc equals 5 pi, and we would like to find out radius, length. We haven't radius here. To find R, I remind you with magic triangle again, L, theta rad, and R. If we'd like to find R, we divide L over theta rad. What is this angle? Its measure equal 90 degrees. Okay. What 90 degrees in rad? 90 degrees in rad equals pi over 2. Okay. Or if you doesn't get it, you can multiply 90 by pi over 180, and you will find out that it equals really pi over 2. So radius here equals L, which is 5 pi, over theta rad, which is central angle here, which is equal pi over 2. So radius equal 5 pi times 2 over pi, cancel pi with pi, will equal 10 centimeter. So radius here equals 10 centimeter. Okay, let's move to another question for you. Okay, we have another question for you. If we have a circle like this, and we have a point outside the circle, and OB is a tangent, and OC is another tangent, and we have the center equals M, is M, and we have joined MB and MC here. From preparatory 3 studying, we know that OC is a tangent and MC a radius, so here it's a right angle triangle, or it's right angle. Here is right angle too, and we have OM. OM here equals 12 centimeter, and we have here the radius equals 6 centimeter, and this is 6 centimeter, and he wants to find out the length of this arc, and the length of this one. We call the small arc minor arc. This is minor arc, and this is major arc, and their sum equals the whole circle. So we have noticed that we have here 12 centimeter for OM and 6 centimeter for BM. So what is this angle? Yes, excellent pupils say that this angle equals 30. So this angle equals 60 here. Okay. So the whole angle here will be 120. So theta degrees equal 120 degrees. We must convert it to rad. So multiply 120 by over, yes, 120 multiplied by pi over 180. خلصنا؟ Okay. Okay. So theta rad will be cancel 0 with 0. So it's 12 over 18 pi. To find the small l, we call it L1 here equals theta rad multiplied by r equals 12 over 18 pi multiplied by 6. And L2, the major one, equals theta rad, which is 240 multiplied by pi over 180 will be 24 over 18 multiplied by 6, and you can calculate it using calculator. My dear students, thank you very much for concentrating. Until we meet again next week, inshallah, have a happy day and good luck.